all right. Welcome to one more session of your WOC. This is your Vani ma'am. How are you all doing, students? Yes, good evening to all my wonderful students. To all the students who are watching me for the first time, welcome. How are you all doing? Let me give you a smiley first. Yes. Happy, stay happy always. And to all the old students who are there with me since long, thank you so much. Okay. All right. In our journey to our board examinations, nothing to worry. I'm taking you gradually towards your board examination. Follow me. Already trick series has started. We are ahead. We are watching. We are going ahead every time. And I'm also giving you a labeling you which day which series is going, right, students? So follow me without wasting time. Simple. Let's start our day 7 series. This is a day 7 series. All right, welcome. So today, as I said, we are going to study the most important 9 questions, very 9 important questions of aldehydes. I'm going to teach you the questions and answers also. If you practice these questions, I'll surely say you will be able to do sure short. The complete chapter of aldehydes is done. This will include all the things, everything is included in this particular series, this particular video. Let's start the video. Don't waste time. Let's start. Welcome. Suppose in the examination, if such type of question, this is compulsory question which is going to come. Suppose if they give you an alkyne in the particular exam paper and on the arrow they have given you water and below you're seeing an acid like sulfuric acid or mercuric sulfate, nothing, students. What they've given you a particular reactant. Like they'll ask you what is this A. They'll simply ask you what is this A. They'll put you a given an identification based question sort of thing. Then from this A, what do? They're going to give you Grignard's reagent, NCH3, MgBr. Everything is easy. Just if you understand the concept, it is easy for us. And they give you B here. After B, they're going to give you on the arrow potassium dichromate, K2Cr2O7 and sulfuric acid. They're going to give you C. Simple questions. Such questions are easy. If you understand the concept, everything is easy. Let me make you understand the concept first. First concept here is whenever you see the first reagent, I'm talking about reagent. Okay, the reagent 1. Reagent 1, if you take mercuric sulfate or acid, sulfuric acid in presence of water, it is nothing but acid catalyzed hydration. Correct? You'll directly add water into this alkyne. Reagent 2, if I take Grignard's reagent, that is addition reaction along with hydrolysis will happen. Okay. Reagent 3 is nothing but oxidation. Simple, no? Simple. Let me do the question and give it to you. How it's. Now, what did they do? First, they have taken alkyne, correct? What did they do? They have added water to that and in the presence of H plus ion mercuric sulfate. So, directly this goes and adds, correct? Water molecule breaks and I'll be getting CH3 here, bond breaks and aldehyde here. H2 here, 2 times broken and water here. So CH3, CH2, aldehyde is over. Next, you're getting Grignard's reagent. Always remember Grignard's reagent on hydrolysis controlling the reaction. Aldehydes in the presence of Grignard's reagent are getting converted to secondary alcohols always. So nothing, directly take aldehydes. You write secondary alcohols. Simple. Secondary alcohols over. This is secondary alcohol. And this is your last. And last one, what did they do? Potassium dichromate K2Cr2O7 and your KMnO4. What did I say? Oxidizing agent. So in the presence of oxidizing agents, secondary alcohols, remember, always on oxidation, they get converted to ketones. So what is a ketone here? Oxidation process, removal of hydrogen. Yes, oxidation is addition of oxygen or removal of hydrogen. Take out this hydrogen, and what are you left with? You're left with ketone. Easy peasy. Let's see one more question. Next question. So let us name this as question number 1. Done. Now see, let us see question number 2. Suppose in this particular thing, only 9, easy. All are easy, we can do it. In question number 2, if they have given me propanone, okay, then what did they say? They have given me I2 in this reaction. I2, oh nice. What is I2, students? What is that reaction? First reagent. Okay, let me write the question completely. A, and then they have given me silver and you're heating that reaction and getting B, and after that After heating, you're using again dilute sulfuric acid, done, and you're doing hydrolysis. Dilute sulfuric acid, you're doing hydrolysis. C. Simple. Tell me the first reagent. What is the first reagent? Reagent one is iodoform reaction. Okay, all right, iodoform is going to form, then that is A. And in the presence of silver, what do you do, student? AgI precipitate out, and you get converting it into alkynes. Perfect. That precipitation comes out silver iodide, and your alkyne is formed. And in reagent 3, dilute sulfuric acid, what does it do? It's going to, and water also is there. It's going to convert the alkyne to aldehyde. Correct, no? You're adding, as I just now said, hydration reaction. Your water adds to the alkyne and you get. Okay, let's see the answer and see. So what did I do first? I have taken propanone. Okay. Then what did I give me? They've given me iodoform. I2, NaOH and heating. Iodoform reaction. Yes, you very well know. This breaks and you're going to get CHI3. Sorry, CHI3. Let me break this. Again take CHI3. Okay. Iodoform, the hydrogen atom replaced with the iodine and CHI3. And silver, you're heating it. Just now I said it will precipitate out with the iodine and I'll be getting alkynes. Done. After alkynes, what am I trying to use? Dilute sulfuric acid. Now dilute sulfuric acid is what? Hydration. This hydration reaction, as I said, this bond breaks. Your 2 hydrogens here, oxygen here, you will get acetaldehyde. Question number 2 also is done. Question 2 done. Easy. Let's see question 3 now. In question 3, one more variety which they're going to ask you is, again, they'll give you ketone because aldehydes, ketones, a chapter only, no? Yes. So ketone is given to you, propanone is given to you, and HCl is given to you. This is one more type of question which they ask you. Then after that, they're going to give you hydronium ion. Okay. Then they'll give you option B. And then they're going to give you sulfuric acid. These are all the different combinations. And heat. And they'll give you options. What is it? So first of all, HCl, nucleophilic addition reactions where we get cyanohydrins. Second, H3O plus where your cyanohydrin whatever is there. Yes, it gets, tell me students, it gets converted to acids. And finally, sulfuric acid, as I said, dehydration, it will remove the water molecule and you get the product. Shall we see that? Chalo, let's see. So first of all, CH3COCH3, cyanohydrin. Where does the bond break? H plus Cn minus. This is where there is a point of attachment where you get CH3. Your C is here and your Cn, cyanohydrin, OH, and your CH3 is here. What is this called? This is called cyanohydrin. Cyanohydrin, which is the A compound. Then after that, you're taking up hydronium ion. As I said, hydronium ion converts the cyano part into acid part. So CH3C, your COOH is formed, your OH is here and CH3. Finally, you are removing water from this molecule. Yes, when you remove water from this molecule, from where you will remove water from this molecule, students? You will remove water of hydrogen from here, OH from here, H2O. And what product you will get? I'll be writing the next page. So the cyanohydrin part, whatever is formed, yeah, the particular thing after dehydration with sulfuric acid, as I said, from here 2 hydrogens and from here 1 OH, you'll be getting sulfuric acid, you'll be heating it and you'll be removing water molecule. Finally, I'll be getting an alkene. And this alkene, how do you name this alkene, students? You name this alkene as, you're naming it as 1, 2. You're starting numbering it as this. So, no, 1 minute. This is carboxylic acid. All right. I have to name it from 1 and 2. To the second carbon, this is a substituent, right? So, to the second carbon, this is the second carbon, this is the first carbon. So, this is 2-methyl propionic acid. 2-methyl propionic acid. Propionic acid, right? That is easy. One more variety shall we see? The same concept. Same concept. This is question number 3. Question number 3 is, question number 4, student. Question number 4 is, here they're going to give you acetaldehyde. Okay. Now, those are the combinations with all ketones. Ketones, different types of questions are that. Acetaldehyde, they'll give you Ag2O. Now you tell me, students, silver oxide tolerance reagent test. On tolerance reagent, it is an oxidation reaction. Yes, aldehydes on oxidation gives me what? Ketones, CH3COOH. Okay. Now see, let us see. Now they'll be giving you PCl5. What is this? This is nucleophilic substitution reactions. So the OH group is replaced. I'll be getting CH3COCl acetyl. Now further, here they're using lead in the presence of barium sulfate. Now you only tell me what is this reduction? This is Rosenmund reduction. Rosenmund reduction. Rosenmund reduction, the acetyl chloride, whatever is there, it gets converted to acetaldehydes because the reduction reaction, you're breaking this bond and you are getting acetaldehyde. Now, acetaldehyde, suppose they give Grignard's reagent. Now, just now I said, no, student, Grignard's reagent, what will happen? Controlled, you're controlling it, hydrolysis also, you're doing final addition is happening and hydrolysis also is happening. Aldehydes on with the Grignard's reagent, always they get converted to secondary alcohols. Yes, I said just now, aldehydes will get converted to secondary alcohols, but because you're doing controlled hydrolysis, the aldehyde group again in the presence of H plus, suppose if they give you, the aldehyde gets oxidized to acid also. What is the name of this compound? This is 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. Propanoic acid. Remember this. Okay, students? Easy. Question number 5. Little more different one I'll give you. Just see. Question 5. Only 9 important questions. Let us do this. Question 5 is, here they're going to give you an alkyl halide. Okay? Same. Now they're going to give you alcoholic KOH. Now you only guess and tell me, alcoholic KOH, what reaction happens? Elimination reaction happens. Correct? Na? If it is aqueous, substitution, it is substitution, and alcoholic KOH, elimination. So what will it do? It's going to break the bond and pull out this bromine and hydrogen. And what will we get? Okay, suppose if I take one more alkyl group here, it's easy for you to show unsymmetrical alkane. Okay, so it's going to break and forms elimination reaction, results in the formation of alkene, right? The CH2. Now, suppose if I'm adding bromine, okay, bromine again, it will break and add around the double bond. This breaks, and I am going to get one compound that is nothing but, what is the name of this compound, students? Name it. It is 1,2,1,2-dibromopropane. Easy. Now, let us take this, and now again I am introducing alcoholic KOH. What will happen? But here in the reaction, they're giving you hydrazine. That is, remember, students, whenever it is giving that, just simple, remove these bromines and shift the bond, double bond, this and this is removed, and the bond shifts to the carbon atom, where I'll be getting your alkynes. Easy. So it is a conversion of 1-bromopropane to alkyne. Yes, I'll be doing conversion videos also. Check it. Next important question number 6. Let us take question number 6. Very important. Again, they're giving you aldehyde with different reagent. Let us see. Now, same concept. Grignard's is given first, but let us see further hydrolysis. What did I say? Whenever Grignard is there, convert aldehydes to secondary alcohols. So now this is propanol. I'm going to convert this into secondary alcohols. It is propanol. Your propanol is there. Here, done. Okay, over. Aldehydes to secondary alcohols. Perfect. Now, to this, suppose they give you sulfuric acid. What will you do? You're going to remove the water molecule. From where you'll remove the water molecule? From here and here, you'll remove the water molecule and you'll form a double bond here. Now, this is dehydration with sulfuric acid, dehydration. So, I'll be getting my alkene back. Sorry, alkene, that is but2ene. Correct? But2ene is what I get. I dehydrated from here and here. Now suppose to this, again, whenever you get an alkene, they ask you to break and add. Break the bond here, add bromine on either sides. Yes, this is your bromine. Again, this is your bromine. And this is your bromine. What is this compound called? 2,3-dibromobutane. Easy? Easy. Next question. Question number 7. Little more easy. Let's see. Suppose they give you a compound, that is, let us first draw the compound. All right. So alternate pi bonds, done. Then I have my, let me first write it, then I'll label it. What is this name of this compound, students? This is 2-phenyl ethanol, no? Correct, ethanol, 2-phenyl ethanol. Now to this 2-phenyl ethanol, they've added one more 2-phenyl ethanol, one more molecule. Okay, again let me draw. In this case, CH. So I'll write that CH in this way. This is easy for me. CH and this is CH. This is easy for me to show. So what is this reaction, students? Condensation reaction. Yes, in the presence of a base, aldol condensation reaction. Yes. All right. Now what do? There is shift of the alpha hydrogen. What is alpha hydrogen? This is your CHO. This is your alpha hydrogen. Correct. So the alpha hydrogen, what happens? This goes and attacks this oxygen atom. And what do I get? I get a compound that is nothing but aldol. So aldol condensation, I'm trying to just show you CH2, the OH bond forms here, and your CH is here, your CHO is here, and your aldol is here. Okay, done, students? Yes, done. Now what is this called? This is called aldol. Now to the same aldol, suppose they're giving me they're heating it and they're asking me, they're adding sodium bisulfate. So let me take this to the next page. So my aldol is here. Next option, this is one more option where they may ask you, that's the reason I'm telling you, they may ask you in this way. The aldol, till here everybody has studied in the school, this aldol formation. Now further to this aldol, what type of question is asked? Handwriting is a little bit bigger, no, students? Okay, all right. So I'm heating this. Done. Then I'm adding NaHSO4. Okay, now you tell me, sodium bisulfate addition reactions, nucleophilic addition reactions. So what you're going to do, you're going to remove water from this. That's all, nothing else to do. When you remove water from this, just careful, everything, this aldehyde will be, it will retain, and you're going to take out the water molecule from here and the bond shifts to this. So how does it look? It looks like this: CH2 CH CH double bond, your CHO, and this is your ring. Okay, done. This is your ring. There's no double bond, students. Okay, what is the name of this compound? B. That's B product. Yes, after aldol you just dehydrated it. Now to this dehydrated product, suppose they are giving you hydrogen and nickel. Oh, reducing agent is given to me. Aldehydes on reduction gives what? Aldehydes on reduction gives, tell me, alcohols. Yes, you're not going to focus on anything, you're just going to focus on this aldehydes. The same compound, yeah, same compound with your CH2. Now your CH is there, the bond is broken, and you're going to convert aldehydes to alcohol, and your ring is here. Now shall we label this compound? Let us see, did I write CH2, yes, CH, the bond broken and added. Now what is this compound? This compound is nothing but 2,4 diphenyl butan 1-ol. Correct, my students? Yes, 2,4 diphenyl 1 2. Okay, 1 2 2,4 diphenyl 1 butan. Okay, so simple. So this is an extension of your aldehyde. Now this is which question? This is question number 7. Let us see 8th. Almost coming to the end. Question number 8. All right. Now here again they have given you aldehydes. Okay. Now they've given you, what did they give you? They've given you aldehydes. Now again hydrazine, I told you, right? Hydrazine addition reaction. Let us see what we can do with this aldehyde. So hydrazine, remove water I said. So shall we expand this and write? This is your aldehyde, right? And this way double bond. Same thing I have written here. Same thing. Now I need to remove water and add hydrazine. From where will I remove? First of all, your CH3, write it directly, your CH. Now careful, your hydrazine from here, this hydrogen and this oxygen comes out. Okay, and double bond will get, it will be retained. How is it retained? It is retained in this form. Okay, this is called what? Hydrazone. Now to this hydrazone, suppose they say they're going to give me heat, just KOH, and they're going to heat it. So what will happen when you're heating? The bond breaks. Yes, the KOH converts the hydrazine to ethanes, alkanes. Now to this alkane, suppose I am adding bromine. Simple, take out HBr and you're converting to bromoethane. To this bromoethane, suppose now they give you alcoholic KOH. Now understand, students. Alcoholic KOH converts alkyl halides. Any alcoholic KOH it converts to does elimination reaction. So this gets converted to ethene. Ethene. This is your problem. Easy, easy. Now question number 9, very important. 1 second, students. All right, students. All right. So let us come and start with the ninth question. Sorry, little bit. I just got a phone call again as usual. So let us do the ninth one and wind it up. Please come on. Yeah. So question number 9. What is that important thing which they're going to give us? So question 9. Let us see this. So suppose if I have acetylene, okay, done. Alkyne is given. Again, they're giving me sulfuric acid, mercury Hg plus 2 ion. What should I do? I should do hydration. Correct? Yes. Now, where will the bond break? The bond breaks here. Two hydrogen atom, one oxygen atom. I'll be getting acetaldehyde. Okay. Now, suppose acetaldehyde, they said they undergo oxidation. Now, you tell me, aldehydes and oxidation will always form acids. Okay. To this acid, they're giving me PCl5 or PCl3 or SOCl2. So nucleophilic substitution reactions, I'll be getting acetyl chloride. Done. To this acetyl chloride, again they're giving me Rosenman reduction. Okay. What did I say? Rosenman reduction. It breaks the bond and converts or reduces or removal of electronegative atom rather. Can I say that? Yes. It converts this into aldehydes. The same aldehyde, suppose you're using Grignard's reagent. What will happen, students? Just now I said aldehydes and using Grignard's reagent will be giving me secondary alcohols.